Today we're looking at net ionic equations. So you'll see on here that these are all double replacement reactions on here. And on our left side we have barium nitrate, and that's aqueous because nitrates are always AQ. Our next substance is sodium hydroxide that has an alkali metal. Those are always AQ. Your precipitate is barium hydroxide. If you look on hydroxides, most of those are insoluble except for the alkali metals. And then we also see sodium nitrate, which is definitely soluble because it has both an alkali metal and a nitrate. So the first thing we're going to do is we're going to break apart anything that's AQ. So for barium, you have to look and see where barium is. It's in the 2+ column, so that's why we wrote Ba2+. Anything that's AQ, you unfortunately have to write AQ every single time when you split things apart. Now in nitrate, there's a 2 there as a subscript, so that means that there are 2 nitrate ions on there. So think of this as the cards. So when we drew the cards, this would look like 1 Ba2+ card and 2 NO3- cards. So when I split this apart, I'm going to have 1 barium ion and I'm going to have 2 nitrate ions. So that's how you're going to write it. So the subscripts that are not part of a polyatomic become your coefficients. Now on 2NaOH, that would look like a sodium card and an OH- card, but there's 2 sets of these, so this would be like if we had 2 pairs on this to balance, just like you kept adding new particles. So we're going to break that apart as 2Na+ and 2OH-. On the right side, this is solid, so you keep that together. You do not break the solids apart. And then 2 sodium nitrates, pretty similar to sodium hydroxide, 2 Na pluses and 2 NO3 minuses. Again, you do have to write AQ for anything that's AQ. We're then going to go through on the complete ionic equation, and we're going to cross out anything that didn't change. So in a double replacement reaction, you get a precipitate, and then the other fluid would be called the supernatant. It's aqueous, it doesn't change, so it's not part of the real true reaction on this. So I'm going to cancel out the 2 nitrates, because they're the same. Barium I can't cancel out because it's in the compound. Sodium is in both parts on here. And then hydroxide is part of the compound, so I can't cancel out. Those things I canceled out up here, I'm going to write on the spectator line on that because they're just watching, just like your fans would at the game, the spectators. What's left then we write together. So I still have Ba2+, I still have 2 OH-, and I still have BaOH2. So that's what's called my net ionic equation. It's what I need to show the actual reaction, the making of the precipitate. So again, whatever is here on your net ionic should be your solid. Occasionally someone might write these for making a liquid instead, but we'll primarily just do it on the precipitates. All right, so here's the steps we went through. We're going to write the net ionic chemical equation on there. So on this, you may have to predict the products on here. Whoops, I just realized that this should say on here the whole, yeah, that should say balance. It's my bad on here. Chemical equation. You may have to predict the products. They're all double replacement reactions. And you're going to add states using the solubility chart. So let's practice doing this now. And if you think something is soluble, you're going to write AQ. And then it's S. So go ahead and try these first in your own and then come back and check. Okay, so in calcium chloride, we have a halogen, and most halogens are soluble with a few exceptions. That would be silver, lead, and mercury. We don't have one of these, so this is AQ, and that is because this was soluble. PBBr2, now most halogens are soluble except for lead is one of these on here. So this is gets an S for solid, but remember that means insoluble. LiNO3 has both an alkali metal and a nitrate, so that is AQ, and again because both of those are soluble. And then Na2O is sodium oxide. Sodium is an alkali metal, so this would also be AQ and soluble as well. So the best things to know are alkali metals are soluble, nitrates and acetates are soluble. The 3 that should always make you think of that there's definitely could be a precipitate or silver, lead, and mercury. However, they would be soluble if they are with a nitrate or an acetate. All right, so now we're going to write the complete ionic equation. So complete is going to include all the ions, just like it sounds. So you're going to rewrite each of the soluble ionic substances that say AQ as separate ions. You don't take apart anything that's insoluble that precipitates, and if it was a gas or liquid, you wouldn't either, but 99% of the time we're just dealing with precipitates on there. Remember when you break something apart that there's more than one of, for example, CaCl2, I would write this as Ca2 plus and 2Cl minus when I break it apart. And again, they would both need to be AQ. Sorry, this is hard to read. So now we're going to write the net ionic equation. So we're going to cancel out anything that is the same on both sides. So in our example that we had up above, on here, we had some substances that were written the same on both sides on there. And what we did is we canceled those out if they looked exactly the same. So in our previous example on here, our spectators were the sodium and the nitrate. You then rewrite what's left, and this is your net ionic equation. And watch out for ones where it would say like 2, 2, and 2. If that would happen, you would want to cancel those out and leave your reaction as simple as possible. So I shouldn't see like 2Na plus 2Cl minus makes 2NaCl. You would simplify that and say Na plus Cl minus makes NaCl. Actually, that wouldn't be a precipitate, but let's say Ag plus Br minus makes AgBr. All right, so let's look at our example here. We have lithium carbonate, calcium bromide, both AQ, because alkali metal and the halogen. On the right side, we have lithium bromide. That's AQ because that's an alkali metal. And then some carbonates are insoluble. Calcium carbonate is chalk, so that's one of them. So I break it apart. So here there's 2 lithiums, so that's why it says 2Li plus. There's just one carbonate, but if it's a polyatomic, I have to look up its charge, so CO3 2 minus. Over here, there's 1 calcium, but there's 2 bromines. So calcium's in the 2 plus column, so Ca2 plus. There's 2 bromines, so 2Br minus. On the right side, lithium's in the plus 1 column, but again, there is a 2, which applies to both of these. So 2Li plus and 2Br minus. And then finally, CaCO3 is your precipitate. You don't cancel that out. So now we're going to write what's left. So I see I have CO3 2 minus, I have Ca2 plus, and I have CaCO3. So that's my net ionic equation. Notice the 2 on the left are AQ and the 1 on the right is solid. What I canceled out here was the lithium and bromide, so I wrote those as my spectators. All right, so on this next one on here, I have given you the complete ionic equation. And I want you to try this on your own, so try and simplify and write what's left. So go ahead and pause the video here and try it, and then come back and check it. Okay, so when I look at this, Ag plus is in the compound on the right side, so I can't cancel that out. However, nitrate every single time is going to cancel out. Sodium is Na plus in both of those. And then Br I can't cancel out because it's in the compound. So what I should write is Ag plus Br minus makes AgBr solid. What I canceled out here are spectators because they were just watching. They would just be floating around in solutions. All right, so in this last one, I want you to try this on your own, doing the whole entire thing, and then you can come back and check it when you're finished. Okay, so on the left side, I broke everything apart. Lead, you have to figure out here is lead 2 because there's a 2 here in acetate because acetate's just -1. There are 2 acetate ions. If you don't know the charge, you have to look it up. Potassium's in the first column, but the coefficient means there's 2, and then same thing with F. It's in the -1 column, but there's 2 as well. PbF2 on here. All right, sorry, and this PbF2 should be solid. Ignore that for a second, because lead is a reactant that is not soluble with the halogens, one of the few exceptions. All right, so that means PbF2 is going to stay together. And then the 2 potassiums and the 2 acetates are going to break apart. So now I look and see what I can cancel out. So let's cancel out this. And then the potassiums cancel out. So my net ionic equation would be Pb2 plus 2F minus makes PbF2. My spectators would be what I canceled out, so that would be the acetate ion and then the potassium ion. All right, and that's net ionic equations.